Good morning everyone. This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about the engineering typology subject. So actually this in the engineering typology subject is a part of engineering studies and as well as in material science also. In this, mainly the major parameters are friction, wear, and lubrication. So today, I want to discuss about the surface treatments. So what is this surface treatment? And how many types of surface treatments methods are there? So how to minimize the wear and friction by using these surface treatments, we will see in this session. So in the part of introduction, the surface of the manufactured product must be processed to ensure certain characteristics and properties, which is known as surface treatment. So whatever you are manufacturing the product, that must ensure some characteristics to resist strength, to resist the wear, to resist the friction. So like this, some characteristics it must have, and some properties also it must have the product, whatever you are manufactured that product, the final product. So then only that product, your designed product will be success in the market. So properties like chemical properties and mechanical properties. So many electrical properties, many properties are there. So according to the application, the type of material, these properties, the material, the final product should have. To ensure these characteristics and properties, some coating methods, some heat treatment methods are required. These type of treatment methods are called as surface treatment. So mainly it is used to improve the properties of the product surface. These processes are sometimes referred to as post processing. So after completion of product, they play a very important role in the appearance, function, and life of the product. So all these treatments, the surface treatment methods play a very important role. So appearance wise and life and cost wise also it plays a very important role. So broadly, these are processes that affect either a thin layer on the surface of the part or add a thin layer on top of the surface of the part. So it affects the thin layer of the surface of the part itself only, or otherwise you can add some extra layer on the top of the surface of the part. The applied the thin layer is called as surface treatment or surface coating. So these are different coating and surface treatment process with different applications, uses, etc. So the important uses include, so given here some advantages of the surface treatment. Why should we do these surface treatments? You can control friction and wear So whenever two surfaces are in relative motion, there is a friction, there is a wear. So to control this friction and wear, so we can't eliminate permanently this friction and wear, but somewhat we can minimize, reduce the friction wear by using these type of treatments. Next, improve resistance to corrosion and oxidation. So resistance to corrosion, you can avoid the corrosion, oxidation. So whenever your component, your product placed in outside due to the environmental conditions, sometimes corrosion and oxidation also may be happen. So to avoid this corrosion and oxidation, you can apply some coating and some treatments. So change physical property. The physical property also you can change by using this treatment. Alter dimension, you can change the dimensions. You can increase the thickness of the product by applying these coatings. Improve appearance and provide a glossy structure, and reduce cost. You can improve the appearance of the product, look wise appearance, and provide glossy look, fine finishing you can apply. So improving the hardness also, by using these treatments. Some treatments are there, mechanical surface treatments. By using these mechanical surface treatments, you can improve the hardness of the material. So similarly, improving the wear resistance also. So the treatment that covers the surfaces, conversing coatings, the first one is the oxide coatings. So again, the oxide coatings are three types. One is gun blowing type oxidation, a chemical bath, and anodizing. To avoid, to control the, to minimize the oxidation, you can apply these type of three methods. Next, phosphate coatings and chromate coatings. According to the application, you can apply these type of coatings. And some other methods are there. So in this, the first one is electroplating treatment. So it is basically electrochemical process, which metal is deposited on a substrate by passing current through the bath. So whenever the current passes through the bath, that is the electrolyte bath, then immediately due to the chemical reaction between an anode and a cathode, what will happen? Some amount of metal is deposited on this substrate. So anode is here positive, the cathode is negative. So the anode, the material to be deposited, the cathode, the material to be coated. So the bath is filled with an electrolyte, which has metal to be coated in an ionic form. So I will show you the diagram in next slide. Electroplating. So we are discussing this electroplating, the continuation. The maximum thickness of deposit is about in this 0.05 mm. The materials such as chromium, nickel, cadmium, copper, zinc are common plating materials. The application includes hydraulic shaft and engine cylinders. Hydraulic shaft and engine cylinders measure these applications, the electroplating. So by using this method, you can the thickness of the coating material is 0.05 mm. So this is used to some applications based on the material also. So here shown diagram, anode and cathode. So cathode is negative and then anode positive. So this is the anode is the plating metal and the cathode is the work part. So this the anode and the cathode and work part is dipped into this tank that is called as electrolyte tank, a plating tank. So whenever current passes through this anode, the material to be deposited on a substrate. So here, this is a work part is plating material. So next one is case hardening. So this is a very common process that is used to harden the outer surface of parts such as the mechanical machine elements. That is one is gear teeth, cam, shaft, and bearings, fasteners, pins, tools, molds, ties, etc. So very common process used to harden the outer surface of the parts. The mechanical machine elements, cams, shafts, bearings, all fasteners, pins, or and molds and dies, etc. In most of these types of components, the use involves dynamic forces, occasionally impacts, and constant friction. In this case hardening, therefore, the surface need to be hard to prevent wear, but the bulk of the part should be tough. So, tough material, but not brittle. This is achieved best by case hardening. So, we can achieve the tough material by using this case hardening surface processing. So there are several types of case hardening process are there, but in most cases the chemical structure of the metal is changed by diffusing atoms of an alternate element. So due to this process, the alteration to be to the microstructure on the crystals on the surface. This type of process is called as case hardening. Next, thermal spraying. So in this type of treatment, metal is melted in a specially designed spray gun using oxy fuel, plasma, or other means to heat the sprayed metal till it melts. So the metal is melted. That is specially designed in a spray gun. I will show you the diagram. High pressure gas then sprays the liquid metal, the molten metal. Whatever metal melted in a gun, so by using this high pressure gas, then sprays this liquid metal, depositing a layer on top of the pot, similar to a painting process, layer by layer. So just like painting process. So the applications included aircraft engine components, requiring resistance to wear and corrosion. The aircraft components are always required to resist the wear and corrosion. For those applications, this type of spraying applicable. The mechanism of bonding to the surface in thermal spraying is both mechanical locking and atomic interaction. So there are many methods are there. The common thermal spraying process are: one is flame spraying, known as FLSP method spraying process, plasma arc spraying, and electric arc spraying, EASP, and detonation gun, so D gun process, high velocity auxiliary fuel process, HV2F. So in this shown diagram, the flame spraying. So in this process uses 2760 degrees centigrade. Oxyacetylene flame is used to melt the target. So first to melt the metal, which may be powder, rods or wires. See here, shown the sprayed material, the spray nozzle, this fuel and oxygen inside the entire called as spraying gun. So air passes is there. So in this the fuel and oxygen enters into in this process. So the coating metal. So whenever a high pressure applied, so then immediately this through nozzle, the coating metal sprays on this deposited metal, the parent, which metal is going to be spraying. So that is sprayed material. So layer by layer will be cut the deposited material. The target which may be powder or rods or wires, whatever may be, but first we have to melt the material at 2760 degrees centigrade or in flame. So remaining process are, see, the flame spraying process is target is powder, rod or wire. Energy source is oxyacetylene flame. Plasma arc spraying. The target is here powder, not in the form of rod or wire. Only powder it will take the plasma arc spraying. So gun energy source is here plasma gun. Next electric arc spraying, wire, electric arc, the energy source. Detonation gun, then is target is powder and energy source is spark ignition of explosives. Next one is high velocity auxiliary fuel. The target is powder, energy source is oxygen, hydrogen, fuel. So these are the major methods of thermal spraying. Next process is vapor deposition. So in this process, the layer of deposited material is very thin material, only a few microns. In the vacuum evaporation process, the metal to be deposited is heated in an enclosed oven. Like in thermal spraying, flame spraying. First, this metal to be deposited is heated in a closed chamber with at a high temperature and at a very low pressure. Some of the metal vapor deposits as a thin layer on the pot. So through the vacuum, due to the vacuum evaporation process, so whenever heated this metal in a closed chamber at low pressure, what will happen? Slowly the material will evaporate. The vapors deposits as a thin layer on the required pot. This process is called vapor deposition. So in this shown diagram, the surface can be coated not only with metal but also with some carbides and nitrates or ceramics also. So some methods only we can apply coatings, some materials only, metals only, with help of some metals. But in this case, but also with some carbides, nitrates and ceramics. The typical applications include surface coating of cutting tools, example drills, reamers, punches, dies, etc. All these cutting tools, coating of cutting tools, so done by using this vapor deposition method. The physical vapor deposition technique shown in this diagram. So in this, the substrate is placed here and thin layer coated. The sputtering gas entered here in the inlet and outlet, and sputtering target. The sputtered target atoms, shown some atoms here. So finally, the deposited due to this vaporization, the substrate coated with some thin layer. Just sputtering, it is important because of its extensive use in production of electronic chips. Here, an electric field ionizes an inert gas, that is argon, and the ions are used to bombard the coating substance, the sputtering process. Here, the atoms of the coating material on the cathode, when hit by the ions, are knocked out of the lattice and later get deposited on the surface of the part by condensation process. So in this sputtering process, aluminum sputtering is used to create most internal coating and connections in VLSI chips in semiconductor manufacturing. The atoms of the coating material when hit by the ions are knocked out of the lattice. So later what will happen is material deposited on this the surface of the part with the process of the condensation phenomenon. In vapor deposition due to the evaporation method, the material coated deposited on a part. Here due to the condensation the surface of the part will be done coating. The sputtering process here shown. So vacuum chamber, cathode sheet, and the source material shown. The vapors and the heater, high voltage and anode and cathode. So argon inlet, high voltage passes through this provided provision, and then argon inlet also shown. The source material is shown. So like this the sputtering process will be applied. Next, electroless plating. So mainly in this case the plating is achieved by a purely chemical reaction in the solution that causes the metal to be deposited. So due to the chemical reaction only the metal to be deposited, here no need of electricity. So that's why this process is called as electroless plating. The plating is achieved with the help of chemical reaction. So this process can be used to plate non-conducting parts with a layer of metal. The most common use of this process is deposition of nickel, the reduction of nickel chloride in a solution by sodium. So this type of process is called electroless plating method. In previous we have seen here sputtering and then and vapor deposition methods. Vapor deposition due to the vapor evaporation. But in this case, the electrolyte splitting, this process actually used to plate non-conducting pots. So most the common use of this process is deposition of nickel, the nickel chloride in solution by sodium. So these are the methods called as surface treatments to control the wear, to to minimize the wear and to control the cost of the product. So that's why after designing and after manufacturing of the product must be coated with some materials to reduce the wear and friction, to improve the some mechanical properties, to improve the characteristics, some characteristics of the material, that is depending upon the application. So in tribology subject, so the wear is important and the friction also important, but at the same time, the minimizing and improving the minimizing the wear and improving the characteristics of the material product, or to improve the properties. It may be mechanical properties or electrical properties or chemical properties of the material. Then only the life of the product will be increased. The continuation of this electrolyte splitting, hypophosphate, which causes nickel metal to be deposited on the pot, already told you, non-conducting materials. This deposited metal is not in a crystalline form, so this process is followed by heat treatment and quenching. These two methods are there, the heat treatment methods, the quenching and carbonizing, annealing, normalizing. These all are called as heat treatment methods. So nickel coating is using this method is used for making tool coating that are quite hard, up to 1000 H. So next one is anodizing. This is a very common process. So many common aluminum pots are surface treated by anodizing to give them a different color. Usually black, red, blue, etc. So many common aluminum pots treated with this type of anodizing method. The colors are different colors used in this anodizing method, usually black, red, and blue. The process uses the metal part as an anode. Using electrolytic process, a layer of hot metal oxide is formed at the anode, that is on the surface of the pot. So already we have seen in electroplating. The electrolytic process, layer of hot metal oxide is formed at the anode only. The common examples include aluminum pots such as fixer frames, car body pots, door knobs, and other building fixtures, bathroom fixtures, and racks, sporting items, example baseball bats, and so on. All these all comes under this anodizing process. Next, hot dipping. So the metal substrate, that is called as pot, is immersed in a molten bath of a second metal. So when removed, the second metal is coated onto the first metal. The common substrate metals are steel and iron. The coating metals are zinc, aluminum, tin and lead. The primary purpose is corrosion protection. To avoid the corrosion, the main purpose of this hot dipping process. Next one is the galvanizing process. The zinc coated onto steel or iron, the most important hot dipping process. And the galvanizing process is important hot dipping process. Aluminizing, the coating of aluminum onto a substrate, that is a part, the workspace. Excellent corrosion protection. In some cases, 5 times more effective than galvanizing. So this method is it gives more efficient than the galvanizing process. That is 5 times than the galvanizing process. Tinning, the coating of the tin onto steel for food containers, dairy equipment, and soldering applications. So these all methods comes under this hot dipping process. So these are the surface treatment methods how to apply to the manufactured product to improve the mechanical properties or chemical properties or electric properties and to improve the characteristics of the product. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.